Okay, well, look, thank you for joining me. I'm going to talk today and for the next 8 lessons about human-computer interaction and what that means, and drill down into the topic. So for about 20 years, the evolution of the graphical user interface, it's really revolutionized the way in which people interact with computers. And that's become known as human-computer interaction. So how humans and computers interact. And one of the main ways we do it is by use of this thing. It's called a graphical user interface. So what I'm using right now on my computer is a graphical user interface, right? So it allows me to interact with the computer using my mouse, and I have a screen in front of me, and I have graphical elements that are generally representations of things. And HCI is not just confined to PCs or to desktop devices like Macs. So if you consider a mobile phone, an iPad, a vending machine, self-scan checkouts in supermarkets, all those things have user interfaces, and those interfaces have been designed, and they've been designed so that they're easier to use and faster to use. Now, there's no single definition of HCI. So this fascinating subject will lead you to explore not only the engineering of GUIs, graphical user interfaces, but more importantly, the philosophy that lies behind them as well. So, yeah, so just try and remember this point about graphical user interfaces, because that'll come up quite a lot. So we call those GUIs, and they've evolved, over time. So next slide. So humans and computers interact in many ways, and the interface between the humans and the computers is crucial to facilitate this interaction. So over here on the right-hand side of the screen, let's zoom in a little bit so we can see it. So this is an example of a very earlier interface from Xerox. So, like, what's the first thing that would strike you about this interface? If you think of the color scheme on it, so what jumps out at you? So, say you were to compare this interface with something like this. So this is a modern interface. You all know what this is, don't you? So what's this the interface from? Yeah. So what's this a representation of? Yeah, these are all icons. So the different individual pictures on the screen that you click are icons, right? But in a general sense, right, compare this interface, which is from a modern phone, to this interface. What strikes you as the main difference? So this is an old one. Yeah, the color style, very good. Yeah, so this interface is monochromatic, or it's, they didn't have color displays back then, whereas we do now, So this is an interface from an old Xerox machine. So you were quite limited in terms of the pixels. So the number of dots on the screen, you were quite limited in terms of the fonts that it could display. So it could only display certain type of letters and text. And also the images were limited as well, because of the pixels, the dots on the screen, and because the screen resolution and also the colors as well. right? So these are all examples of interfaces or GUIs, right? And these allow us to interact with the machines. So desktops, desktop applications, internet browsers, handheld computers, computer kiosks, they all make use of GUIs, right? So that's one way that we can interact with machines. So another way we can interact with machines is by using what they call voice user interfaces. And they're used for speech recognition and synthesizing systems. And then you have GUIs or interfaces that are what they call multimodal. So we interact with them in numerous ways. And that feedback then can be output, or we can get feedback from the device, right? So could anyone give me an example of a voice user interface?
I think, sir, listening to music.
Yeah, well, listening to music, right, is I suppose when you receive information from the device. Okay, so how would you give information to the device using your voice? Yeah, okay, and we have a couple of good suggestions in chat, right? Google Assistant and Siri. So I can use my phone here. So I go, hey Siri, what time is it?
It's 8:10 a.m.
Yeah, so you can hear that, guys. So that's an example of a voice user interface, right? And then in the background, you have the device converting my voice into a, something that it can understand, and recognizing my voice as well, and then carrying out the commands of my voice. So that's an example of interacting with a device, just in a slightly a different way. Because when I interact with Siri or with Google Assistant, I don't use a graphical user interface. So I don't even need to be looking at the device to use it, right? So I suppose just the point I want to make is that there's different ways to interact with the devices, right? And what multimodal is, right? So this,
I know you can.
You can see this line where it says emerging multimodal. So that means a device that would give us, I suppose, output, or it can actually take input as well using multiple senses, right? So could anyone give me an example of a multimodal device? Right. So say if you think of something that you might see with gaming.
Sorry, does it connect to the different generation of the phones, or different like iOS or Android or anything?
Not really, right? So what I'm thinking about, and let me explain a little bit clearer, is I'm thinking about a device that can send me information, right? Either by sight or by sound or by touch. So what I'm thinking about when I'm talking about a multimodal interface, right, is maybe something like a haptic alert on a gaming console. So when you're actually playing a game, right, you're looking at the screen, so you're getting information via sight, right? You also can hear the sound and the sight, they're tied together, but you're also getting vibration alerts, or you're getting haptic alerts from the device or the console as well, right? And that's what we mean by multimodal. So the information is coming in various modes. Now, a lot of phones have it now as well. So I know that my phone has haptic alerts. So when I type, what happens is I get little vibrations through the phone, right? Does that make sense, guys? So these are just different ways that people, remember, this is all about interaction, and it's I suppose, the device and the person working together as best they can. And look, the devices and human computer interaction, it's evolved over a long time, I suppose I just wanted to start off and let you guys know maybe where we've come from. And you have these sort of these kind of displays, very limited, you know, very very gray, not able to render color color sort of visuals. And then we've moved on to something like this, which is a lot more natural, and look, a lot more interesting to look at, a lot more engaging. So let's carry on, right? Let's look at a definition, right, of human-computer interaction, right? So it can be defined as a discipline concerned with the design, evaluation, and implementation of interactive computer systems for human use and with the study of major phenomena surrounding them, right? So I suppose the important word there is interactive, right? Because interfaces need to be interactive. So what does interactive mean? We're to look up interactive. So it gives me this definition: allowing a two-way flow of information between a computer and a computer user, responding to a user's input. Does that make sense? So remember, when we're talking about human-computer interaction, we're talking about both parties. We're talking about the person, yeah, and we're talking about the device as well. Yeah, so communicating or linking in, connecting is a good way of putting it, right? So an important facet of HCI is user satisfaction, or simply end user computer satisfaction. So what do I mean by that? So in this sense, what do we mean by satisfaction? So think you're using your phone, okay, and if you are to continue using your phone, the manufacturers want to make sure that you're going to enjoy using your phone, and also the app developers, they're going to want to make sure that you want to come back and use their app again and again. So this user satisfaction is actually really important, right? So if you were again to compare the two designs, say the new design with the old design, so which do you think is more satisfying to use? Our new design or our old design? Yeah, the new one. And why would it be more satisfying to use?
I think so. The graphic also, and also the quality of camera.
Exactly. Yeah.
Yeah.
Yeah. Excellent. Yeah. Good answer. All the features on the phone lend itself to being more engaging, more satisfying, more just more interesting, but also probably more natural to us as well, you know, because we see in color, most of us do anyway, and so using a device like this is going to be a struggle for us, because we're going to look at it and, you know, it just doesn't feel right, or whatever, you know. So this user satisfaction is really important, right? So let me just go through this next section. Because human-computer interaction studies a human and a machine in communication, it draws supporting knowledge on both the machine and the human side. So on the machine side, techniques in graphics, operating system, programming, and development environments are relevant, right? But then on the human side, communication theory, graphic and industrial design, linguistics, social science, psychology, and other human factors such as satisfaction are relevant, right? So remember, you've two branches to the term human-computer interaction. And what we're going to do across this course is we're going to try and look at both of those, right? We'll try and look at the human side, right? Maybe some of the psychology behind some of the choices that we make as people. But we'll also look at the other side, the computer side, or the technology side of things as well. So just, I suppose the point I'm making is there's two branches, or it's a two-prong definition, right? Both, and it has the human element and the technology element, right? And that's important, I suppose, to note at this stage. So this course isn't just about computers. We'll also factor in the human side as well. And then finally, HCI is also termed human-machine interaction, or man-machine interaction, or computer. So there's other abbreviations for the term, but the most important one is HCI, human-computer interaction. Okay, so that's our little intro to the course, right? So now this is a picture from 3 Mile Island, right? Has anyone heard about 3 Mile Island? Can you see that? Yeah, so 3 Mile Island was what year? 1979. So it was a nuclear accident. So a little bit like what happened in Chernobyl, or whatever. And these are the guys that were doing the cleanup after the accident in the nuclear power plant. And when they investigated what happened, they concluded that the design of the interface was at least partly responsible for the disaster. So part of the problem was that the machines in the plant were being operated by people, and the user interface was very difficult to work, and all the dials looked very similar, and the layout was poor, and a bunch of other factors. And it's safe to say that poorly designed human-machine interfaces can lead to many unexpected problems. So the classic example is the 3 Mile Island accident. And yeah, the interface was at least partly responsible for the disaster. Okay, so similar accidents in aviation have resulted from manufacturers' decisions to use non-standard flight instruments or throttle quadrant layouts, right? So even though the new designs were proposed to be superior in basic human-machine interaction, pilots had already ingrained the standard layout, and thus the conceptually good idea actually had undesirable results. So there's two points we can take away from that. So the poorly designed interfaces, or the poorly designed interface in 3 Mile Island, contributed to the accident, right? Secondly, in aviation, they've tried to change the interface where pilots, they change the layout of the switches in the cockpit when the pilots are flying, and they've changed, to what they call non-standard flight instruments, right? But they've always reverted to the previous design, and that they've gone back because they've actually found that the standard interface, or the standard layout of the devices, was what the pilots were most used to. And learnability is a big factor in interfaces as well, because sometimes you expect things to be in certain locations, and from previous experience, and one of the ways you can measure interfaces is in terms of their learnability. So the pilots had all expected the layouts to be in a certain way, and what was a very good idea in paper, you had a designer or a HCI expert sitting down and trying to redesign the layout. It just didn't work in reality. So, and then they always reverted back to their previous designs. So 2 points to take away. Number one, that user interface design is very important, and it can cause accidents if it isn't done properly and tested properly, but then also factor in learnability on systems as well. Okay, so we'll just go through. So that's just a little bit of background on general HCI, what it means, the different types of branches to the definition. And now what we'll do is we'll go through the development of human-computer interaction. And we'll go right back to the 1960s. We'll go through the different evolutions of design, and we'll bring it right up to today. So we'll do this, we'll go through the history for about 10 minutes. And please stop me if you have any questions, just ask a question, or you can post your question on chat. So the development of HCI, so how we've got to where we have today. So one early GUI design was developed in the early 1960s by a graduate called Ivan Sutherland, and he developed a computer graphics program called Sketchpad, which was inspired by research into how humans learn. So this led to developments at Xerox during the 70s, which were based on the WIMP system. So WIMP stands for Windows, Icons, Menus, Pointers. And this concept became available in the early 1980s. So we still use this concept today in modern computing. We have windows, icons, menus, and pointers. So my pointer is my mouse, or my mouse cursor. So if you look kind of carefully at the picture, zoom in a little bit, you can actually see a very rudimentary sort of mouse and keyboard. So it doesn't look totally, dissimilar or different from what I actually might have on my desk here in front of me with my desktop computer or my laptop. So you have the same components. You have a mouse, you have a keyboard, you have a screen, that sort of thing. Right? So this started back in the 60s and then developed in the 70s into this WIMP system that we still use. Windows, icons, menus, pointers. Okay, so then I suppose that design was popularized in the 1980s by Apple Mac, and the Macintosh computer appeared. So these machines successfully made use of GUIs in the form of a computerized desktop with icons. And icons are small graphic images, papers, desktop files, a rubbish bin, these sort of these concepts. So these were popularized in the mid 80s by Apple, and we use a very similar system today, where we have windows that we can move around the screen, right? We have layers in the windows. So you'll notice that the window that I'm working on right now is the one that is closest to me. So we have this concept of layers, where whatever I'm working on now is in the front, and whatever I've been working on is in the back. And you can switch between layers. You have these icons, like the trash icon, and when you pop something in the trash, it might make the sound of a piece of trash, and all these sort of concepts to try and make things more lifelike. And this concept, with the addition of a mouse, enabled the user to easily locate documents and click to open them, as well as pick up documents and put them in the bin. So if I had a file, I can grab the file, I can physically pick it up, or if I click on this icon here, I click and I hold, and then I can move the icon around. So these were quite revolutionary concepts at the time, and they really changed how people interacted with machines. So this early Apple desktop computer design truly revolutionized and influenced how users interact with computers today. And it's provided access to the world of computerized technology to millions of people. And then, of course, Apple did exactly the same thing again some years later. So what was the second device that they came up with that had quite a revolutionary system? There's been maybe three. So if you think of this computer device as the original device, well, what was the next device they redesigned, and it fundamentally changed how people used and consumed? So what was the next big device for Apple after this? Does anyone know?
I think so, iPhone 14.
It could maybe before the iPhone. So what came before the iPhone?
iPhone 13 Plus.
Yeah. So even before the phones. So does anyone remember these?
iPad.
An iPod. Yeah. So it was the way. It was just a new way at the time for people to consume music. And again, it was quite clever in that you had a very simple way to interact with the device. So you just had a sort of scroll wheel down here, and that moved up and down. And then when you got to the song you wanted, you pressed click. So Apple have done this in terms of design 3 or 4 times, going right back to 1984, and this concept of windows and pointers and icons and all that WIMP stuff we spoke about. And then they've done it again in terms of the iPod, and fundamentally that changed how people consumed music, and they've done it more recently, like in the example you gave, with their iPhone designs. Right. So again, Apple would be a big part of the story of interface design. Okay, so we'll move on, right? So historically, early HCI designs were restricted by the hardware available, and users were required to type in lengthy code just to log in. So the highly popular Commodore 64, which is this, is one such example. And at the time, no GUI requesting a username or password existed. So my cousin actually used to have one of those computers, and you would turn the computer on and it didn't do anything. You had to know how to do even the most basic task, because it was this command line prompt, right? And that meant the computer responded to text input. So you needed to type in the commands, and then you'd hit return, and then the computer would carry out the command that you typed in. But if you made any mistakes, or if you didn't know the commands, or your typing was incorrect, then the computer wouldn't be able to do anything. So in those early designs, when switching on the computer, the user would be faced with a blank screen with just a C prompt, as with operating systems such as MS-DOS. And the user required knowledge to interact with the program, as drop-down menus and GUIs had yet to be invented. So this was right before that. So another device, or another way of interacting with a machine, is through what they call a command line interface. So this is different from a GUI system where you've got icons and windows and a pointer and a mouse and this sort of stuff. So this is text-based commands where you actually type in. So on the top you have this is the command prompt on Windows, and down the bottom here this is the terminal window on Mac OS. And what it does is it asks you to type in your instruction, you hit return, and then you get information back from the computer in the form of text. So very difficult to use and very specialized to use as well, because you not only need to know the language to type in, you also have to interpret the results back. So you get back a whole load of stuff like this, and you have to try and understand it, so it can be difficult. But again, another way to interact with the device, it's called a command line interface. Right, so before the introduction of GUIs, the only way to interact with computers was to enter a series of codes into the computer's operating system. For example, the user would go into MS-DOS and the C prompt would appear on the screen. And by entering a series of codes, the user could create a structure such as copying, renaming, and moving files. And such structures and methods are now built into modern day computers, but they're accessible through other means. So how would we, how would we do that on a modern day computer? So if I wanted to copy a file on my computer, how do I do that? And say this image, right? Say I want to make a copy of this image. How do I do that? Control C, yeah. And then paste. Now I have. Yeah, so it's that quick. So I'm on a Mac, so I'm hitting Command C. Another way, I click here, I go copy, and then I go and paste. Yeah, so much more, and then if I want to change my mind, I can go back. So much more convenient, right, and much more user-friendly doing it like that, than typing in, I suppose, a load of codes using a command line interface. So graphical user interfaces. After command line interfaces were around, you had this emergence of graphical user interfaces. Much more visually appealing to look at, far more interactive, far more natural, far more learnable, right? So the graphic user interface is a form of user interface that allows users to interact with electronic devices through icons and audio indicators. So instead of typing text-based commands and of having to navigate, a text-based screens, GUIs were introduced in a reaction to the perceived steep learning curve in command line interfaces. So I suppose, look, they got invented because these type of interfaces where you typed in the codes for the computer to respond to were just very difficult to use. And people struggled to use them. It was very specialized knowledge. So the actions in a GUI are usually performed through direct manipulation of the graphical elements. And beyond computers, GUIs are used in many handheld mobile devices, such as MP3 players, portable media players, gaming devices, smartphones, and other household items that you might have in your phone. Yeah, could anyone give me an example of a device that has a user interface in your home? So say something from your kitchen. So what devices have user interfaces in your kitchen? Any ideas? Yeah, smart fridge, yeah, because it would have a little screen. The oven, very good. The microwave, the dishwasher, the coffee machine, all these different devices have, interfaces. So they have some sort of a menu system, and you need to go in and you find what you're looking for. A washing machine could have a screen, or it could have a series of dials, and you twist the dials to get to the program that you want. So remember, it's not just computers and phones and that sort of stuff. So if you think of all the items that you use, even the way you interact with a car, right? Or the way that, the train driver drives the train or the tram. Like, he has a set of controls in front of him. And at some level, people have sat down and they've said, right, put this here, put that there, let's put that dial there, that sort of thing. So these are all interfaces of different types. But generally, when we're talking about graphical user interfaces, that's always or tends to be within the realm of computer science and computers, laptops, phones, those type of devices, right? So the takeaway point is, look, graphic user interfaces, they replaced command line interfaces, and they're meant to be more natural and more engaging. And now you see them on all different types of devices. Right, so another type of user interface that you're probably familiar with, web user interface. So this is the type of interface that you see on a web page, right? So web user interface refers to the interaction between a user and software running on a web server, right? Now, so if we take this and I'll zoom in a little bit. If we take this as an example of a typical web page. Up the top here, you have your address bar, you have the icon for the site, and then down here you have different sort of categories, and they all seem to be grouped by color, and that you've got yellow, red, blue, and green, this type of stuff. Up the top, then you have a sort of a navigation system. So this is like the main navigation up here, and this is the secondary nav, where you get to go in to like a second layer of information. And this is what's known as a web user interface, right? So web graphical user interfaces, they're platform independent, and they don't require any installation. So I don't install the website on my machine. I just link to it, or I link to the web server using my browser. So using Safari or Firefox or Internet Explorer or one of these applications. They're easy to update. So if the web developer or the company wanted to make a change on this, the next time I visit the site, I can see those changes and that sort of way. So so they provide a vibrant user interface experience and a low cost for me as the user to access, right? So that's just another example of an interface, and we call them web user interfaces. So if you think of any website that you've visited recently, when you go in and you interact with the menu systems on the site, and you go and you click around the site, you'll see how the information is grouped and how it's structured. But again, an example of another type of interface. So we'll look at maybe more specialized interfaces for a couple of minutes. So the user interface is the way we interact with our computer systems. And information systems have specialized interfaces which are designed with the user in mind. So if an information system is for users with a wide range of needs and abilities, designers must ensure it's flexible enough to suit them all individually, right? So what you're talking about here is maybe a user cannot use a computer or a phone or the interface in a traditional sense. So they might struggle to use the mouse, or there could be mobility issues, sight issues, all these different things. So then there is like an onus on us as developers to try and develop interfaces that are as, inclusive as possible. So you have things like voice recognition software, screen reading software. I've seen head wands, eye tracking. We have keyboards for people who, struggle with their sight, those type of things. And specific users should be taken into account when designing, creating, and testing information systems to ensure that it meets their needs. So you're talking about all different types of users, really. You're talking about young children, right? Inexperienced adults, users with learning difficulties and disabilities, users that might require voice recognition to control the operating system, users using a specialized output device to read the screen aloud, all those kind of things. And what that does is it makes the computer system more inclusive and more useful, right? But a lot of these things would apply to me as well. I know my phone has a function so that when I'm driving, if I receive a text message, then the phone will actually read the text message to me. So I don't need to look down at my phone when I'm driving. And the more adaptable these computer systems are on these devices are, generally the more useful they are to, to a lot more people. Right. So I suppose, look, as interface designers, it's important to bear in mind these factors when we are designing and constructing interfaces. Okay, so the visual layout, right? So now if you just very quickly compare this layout, so this is a web page. So how do you find this to use? So if you just look at that very quickly, what does it strike you as? So does it appear easy to use? Yeah, it's really bright. So the colors are a little bit off almost, right? So too many colors? Yeah, the fonts. Look at all the fonts are different. So there's no uniformity. Now, if you wanted to find something on that, is it difficult to find what you're looking for? Yeah. So it's hard to, it's hard to find what you're looking for because you've got all these separate things, grabbing for your attention. So if we compare that to the other web user interface, so this is a really bad example of design, right? This one. So how does that strike you? See the way everything is more structured and it's in separate areas and it's got different colors that draw our eye to the area. So this is much more, it's much easier on our eyes. So there's our good example. There's our bad example as well. And you don't know if that's a web page, you don't know where to click or what to do with it or anything. So this is in terms of a visual layout. So the information system should have an appealing layout and color scheme, right? And it should be eye-catching, simple to use, and clear of cluttered buttons and text. So you're looking for things like consistency, easy to read fonts, and color scheme, a consistent look across pages, well-organized pages with no areas and links and text, and everything is wrong about this. So all the images, they're not aligned, it's just, yeah, and even then the background as well really catches your eye, right? Designers also consider the devices that will be used to view the information system. So you have to think as well, where is my information system or where is my interface going to appear? Because it's a very different thing looking at a phone than it is from looking at, you know, a big smart TV or something like that. So when you're thinking about trying to design an interface, sometimes you have a particular device in mind, and you know as well how much screen space that you're actually going to be working with, right? So this, just take this as an example of a very bad design. Bad because it's not consistent. Everything's cluttered. The images, just everything's wrong with this. So the visual layout of the page is just poorly put together. This brings us on to navigation. So your navigation then on your site is how the users move around the site. So we'll give you a site with, I'll give you an example of, say, navigation. And so we go to a site like Apple. It's very well thought out and well designed. So where's the navigation menu here? So here's my main navigation, right? And then as I go down the page, I get options to go into, you know, other areas of the site. But you can see that this banner along the top doesn't really change. So these are the main categories of the products that Apple, you know, offer me. So, and each one of them, when you click into it, you'll get sort of almost like a subcategory where it pops up. So if I click on Mac, it'll show me all the computers I can buy, you know. But again, it's given me text to work with. It's given me a graphic to look at. If I click on the phone, it'll give me a list of all the phones that I can buy. So generally well put together, very consistent color schemes, nice pictures, this type of stuff. But this main area across the page is known as your main navigation, right? And you can actually see that the site follows a kind of a hierarchy, or you can get around it using certain means. So this is like your home page, and then after your home page, you have options to go into secondary pages, and then you have another layer. And most websites are put together using this hierarchical sort of structure, right? With some menu systems, you see a different type of structure. You see a linear structure. So this is more like the pages in a book, where you have to go 1, 2, 3, 4, 5, and then you're back to the start again. So you see a lot of menus on TV systems like that, where you have to scroll through different pages and what have you. So again, look, the point I'm making is that the navigation of the site is important, and generally this hierarchical structure is one of the ways that that designers put the site together, and it's what we're used to looking to as well. You know, if you go to any website, you'll see these examples of you know, a landing page, secondary pages, sub areas on pages, all that kind of stuff. So that learnability is a factor as well. So selection is the way a user makes their choices on the information system, and different levels of user experience will influence which type is used. So modern computer systems use WIMP interfaces, where the users have windows, icons, menus, and pointers. So if I'm using this slide software Keynote that comes with Mac, so if I click here, these are all the different commands, right? So I go into the top, and then I go down, and then you see the secondary kind of commands that are available to me. You see those appear, right? So this is a WIMP system. So remember, windows, icons. So the icons are just, you know, graphical representations. So these type of things, folders and windows and menus that you can click on, and then they appear. So that doesn't appear until I click. and then my pointer, which is my mouse. So smart TVs, websites, and smartphones make use of icon-based selection. But sometimes they also have the ability to use text entry, right? So you might have the option. So if I go in here, see, it even shows me where. So if I'm looking for a command, so something obvious like save. So I type in my search. So it's like a search engine for the app. And it actually takes me to, so it shows me which menu the particular thing is in. So there can be different ways to find things on different websites. So a well-designed user interface will have a combination of buttons and images to use, as well as links. It'll have text-based links and the ability to type in specific searches, right? So that ability to search as well is kind of like a catch-all. It can be very helpful for users as well. And you see it on a lot of interfaces and a lot of websites. So say I use this example. This looks like some sort of a console or a smart TV, and you can move around the interface and you use the arrows. You go up, down, left, right, a little bit like the way you scroll around on Netflix or something like that. And then you make your selection, but you can also pull up a keyboard and you can actually type in a search and it'll give you results back as well, right? The key to all that, I suppose, is consistency. And to allow users to easily navigate and interact with the information system, each page and facility should be consistent. And each page should have a similar layout with similar colors and fonts used. And pages and navigation methods should be consistent with link and search facilities located in the same areas, right? So just think of our bad example. Again, right? Everything is jumbled. Everything is just feels off. The colors, the icons, the size, the fonts, all the components of the page that we expect are, I suppose, you know, not as they should be. Think of a good example then, something like, you know, one of the Apple website, the Netflix app, these type of things, where everything is nicely grouped together. You've got nice colors, you've got consistent fonts, you've got all those sort of things, and everything is just, you know, easier to use and more visually, I suppose, appealing for the user, right? So that consistency then in user interfaces is really, really important. Okay, so any questions? I think we'll kind of wrap it up for this morning, guys. So any queries or any questions before we finish up? So that's a brief run through, just an introduction to human computer interaction, maybe a little bit of the history and a little bit of background on different types of interfaces. So interfaces, the graphical user interface, the text-based interface, and maybe some of the things that we expect to see in interfaces. I mean, this will give us something to build on then as we progress through the course.